Hey everyone, and welcome to this explainer. Today, we are finally going to settle it, the great gRPC versus Apache Thrift debate for modern microservices. You know, if your engineering team is evaluating RPC frameworks right now, or maybe you're staring down the barrel of a massive microservices migration, well, you are absolutely in the right place. We're going to bring you a really clear, actionable, and totally stress-free roadmap derived straight from the latest architectural guides. We'll dive into the hard data, peek beneath the hood at the underlying protocols, and figure out exactly how to navigate this choice for your specific team. Okay, so here's our roadmap for today. 1. The cloud-native verdict. 2. Beneath the protocol surface. 3. Performance under the hood. 4. Choosing your framework. 5. The migration playbook. And finally, number 6, the big picture for leaders. Let's get right into it. Starting off with Section 1, the cloud-native verdict. All right, so bottom line up front, the verdict from the architectural data is totally decisive. gRPC wins. It just dominates. And you might be wondering why. Well, because choosing a framework in today's cloud environment is about way more than just what code you're familiar with. gRPC simply has vastly superior tooling and a much stronger ecosystem backing it. Plus, it gives you incredibly tight integration with the modern infrastructure you're probably already running anyway, like Envoy proxy and Kubernetes. Now, the source material does explicitly note that Apache Thrift isn't dead. It remains relevant in some very specific scenarios. But if you're choosing it for a brand new project today, you really need a highly deliberate reason for that, not just because it's what your team happens to be used to. Moving right along to Section 2, beneath the protocol surface. Let's actually look at how these protocols differ, because honestly, the similarities pretty much stop at basic binary serialization. So on the left side, we've got gRPC. It is incredibly strict. It runs entirely on HTTP/2, it exclusively uses protocol buffers for serialization, and it has this amazing first-class native support from Google, the Cloud Native Computing Foundation, and service meshes like Envoy and STO. Then on the right side, we have Apache Thrift, which originally came out of Facebook. Now, Thrift is transport agnostic. It works over TCP, HTTP, or literally even pipes, and it supports multiple serialization formats: binary, compact, JSON, the whole shebang. Sounds incredibly flexible, right? But here is the catch. That flexibility, it's a massive double-edged sword. In the real world, the source points out that Thrift's transport flexibility actually creates team-by-team inconsistency. Different teams end up picking different transport and serialization combos, and suddenly you're looking at a highly fragmented RPC layer. gRPC's strict adherence to HTTP/2 and protobuf actually forces an alignment across your teams that fits perfectly with modern architectures. Which brings us to Section 3, performance under the hood. Okay, let's talk numbers. These benchmarks reflect what we're seeing across real-world production deployments. Looking at Go internal service calls, gRPC is the clear winner here. It's hitting a P99 latency of about 1.2 milliseconds, pushing 85,000 requests per second. Thrift? It's a bit slower at 1.4 milliseconds and 78,000 requests per second, but actually, here's where it gets kind of interesting. If we look at Java workloads, Thrift's compact format actually edges out gRPC just a bit on pure serialization speed. It hits 1.9 milliseconds and 58,000 RPS, while gRPC sits at 2.1 milliseconds and 52,000 RPS. So the big takeaway from this data is that when you're just looking at raw serialization speed, they're actually running pretty neck and neck. But wait, the crucial part is what happens next in the pipeline. The source specifically highlights this. gRPC's HTTP/2 multiplexing acts as the great equalizer. While Thrift might squeeze out a tiny edge in pure Java serialization speed, gRPC's native HTTP/2 completely eliminates head-of-line blocking. It's kind of like opening up multiple lanes on a massive highway instead of letting one really slow truck block all the traffic behind it. What this means for you is that under real-world high-concurrency loads, gRPC totally closes any serialization gap. And on top of that, gRPC pulls significantly ahead with its native bidirectional streaming, whereas Thrift streaming feels a bit bolted on out of the box. And those HTTP/2 headers make tracing, metrics, and logging so much easier to observe natively. All right, Section 4, choosing your framework. So when should you absolutely pull the trigger on gRPC? It is your go-to if you're building or expanding on cloud-native Kubernetes architectures. If your app relies heavily on bidirectional streaming or server push capabilities, gRPC handles that natively. You're also going to want gRPC if you rely on Envoy proxy or major service meshes. Envoy is basically the de facto sidecar for gRPC. It handles load balancing, retries, and circuit breaking right out of the box, stuff that takes major custom engineering to pull off with Thrift. And finally, if your teams are mostly coding in Go, Java, or Python, which all have super mature gRPC libraries, and you care about long-term ecosystem support, yeah, gRPC is the clear winner here. But hey, Thrift isn't entirely obsolete. It definitely still makes sense in a few distinct scenarios. First off, if you're sitting on a massive legacy codebase where the migration costs would just completely eclipse the benefits, don't touch it. You should also stick with Thrift if your architecture strictly demands non-HTTP internal protocols, or if you're heavily relying on older C++ stacks where Thrift actually boasts better library support. Or, if your engineering team already has deep Thrift expertise and you aren't facing any immediate pressure to scale. Let's look at Section 5, the Migration Playbook. Say you do decide to migrate. How on earth do you do that without taking your systems down? Well, the source gives us a strict 6-step roadmap for a zero downtime transition. It starts with a really comprehensive audit of your existing Thrift IDL files. Then you carefully translate them into .proto files. Next, and this is absolutely crucial, you run both protocols in parallel using a shim service. From there, you just start migrating your consumers service by service, kicking things off with low-traffic internal nodes to be safe. To handle this awkward transition phase, you use Envoy proxy as your translation layer because it seamlessly handles the Thrift to gRPC transcoding. And finally, once every consumer is validated, you can safely decommission those old Thrift endpoints. But I have to give you a massive warning here regarding Step 2. Protocol buffers are incredibly strict about field IDs. If you mess those up, the system isn't just going to gracefully crash. No, it's way worse. You will silently corrupt your data. The source explicitly warns us, absolutely do not auto-generate your .proto files from your Thrift IDL without doing a rigorous manual review pass. You really have to pay special attention to Thrift's union types. Those need to use the one-of keyword in protobuf, so be super careful there. Now for our final section, Section 6, the big picture for leaders. If you're a CTO or an architect, you need to ask yourself one absolute deal breaker of a question. What does your infrastructure team already support? Honestly, the technical specs are completely secondary to the organizational reality here. Because if your platform team is already up and running on managed Kubernetes, like GKE or EKS, I guarantee you they already know and natively support gRPC. Trying to introduce or maintain Thrift in that kind of modern environment, it's literally fighting against the grain of your own infrastructure. You also have to remember that your protocol choices compound over time. A fragmented older system might feel fine today, but fast forward 3 years. The source notes that gRPC is just way more common in job descriptions and candidate skill sets right now. If you stick with a legacy protocol, it's going to be significantly harder to hire fresh engineering talent, it'll be harder to natively instrument and trace your metrics, and it'll be a real headache to integrate with whatever next-gen cloud tooling comes down the pipeline. So the executive mandate from the architectural guide is super clear and highly pragmatic. If you are building net new systems, use gRPC. There is basically zero debate there. But if you're staring down a migration, you need to carefully, mathematically calculate your exact organizational costs before you try ripping out massive existing Thrift code bases. If the math just doesn't make sense, well, Envoy proxy can help the two coexist peacefully. And that leaves us with one final vital thought to chew on as you evaluate your own backend systems today. Take a really hard look at how your internal teams are communicating right now. Ask yourself, is your legacy RPC protocol quietly compounding your technical debt and slowing down your entire engineering velocity?